Hello, I'm Miss Janet. Most of the time, graph sketching is used to present data obtaining from an experiment. According to a graph, we can know the data trends and the relationship between variables. Today, we are going to talk about graph sketching. Firstly, we can set a problem or a phenomenon to be explored. Then different variables will be set. In the experiment, we would usually deal with the following three variables: independent variables, dependent variables, and controlled variables. Independent variables is that what is cost change in an experiment. That is what would like to be tested. If you want to draw a graph to present these variables, the independent variables will be put on the x-axis. Dependent variables is that what is measured in an experiment. This is the experimental result. These variables will be put on the y-axis. Controlled variables is that what is kept constant in an experiment to make sure that all experiments are in a fair test. Maybe we can use an example to further explain. In this case, we would like to investigate the relationship between resistance and the current. The following instruments will be used in this experiment. In this experiment, we collect different values of resistance to the circuit, and then measure the current of the circuit. The independent variables of this experiment is different resistance. So we will put resistance on the x-axis. The experimental result of this experiment is current. Therefore, the dependent variables is current and will be put on y-axis. And same battery and same set of collecting wires will be kept constant throughout the experiment. Based on the experimental result, a graph will be obtained. From the graph, we can see that the currents decrease due to the increase in the resistance. So we can draw a conclusion that resistance is inversely proportional to the current. Besides the data trend and the relationship between variables, we can also get the physical meanings from the slopes and the y-intercept from a straight line, such as refractive index of different materials. Later on, we will go through a related example. Here is a straight line. It is a linear function. When we write the equation of straight line in y equal to mx per c, m represents the slope of the straight line. We can find any 2 points on the straight line, and for the equation, the slope of straight line can be obtained. C represents the y-intercept of the straight line. It is the intersection point of the straight line and the y-axis. The following example can demonstrate how to use a graph to find the refractive index of a glass. Firstly, we let theta A be the angle of incidence, and theta G be the angle of refraction. In this experiment, the angle of refraction was measured corresponding to its angle of incidence. A set of data will be obtained. According to the formula of refractive index, n is equal to sine theta A over sine theta G. All angle obtained from an experiment will be changed to sine theta. In this experiment, we change the angles of incidence and then measure the angles of refraction. Therefore, the independent variables is angle of incidence, and the dependent variables is angle of refraction. So we will put sine theta 8 on x-axis and sine theta g on y-axis. 5 points were marked on the rectangular coordinate, and then a best fit line was added. Remember that all points should be evenly distributed on 2 sides of the straight line. Now 2 points will be chosen from a straight line. Refractive index is equal to sine theta A over sine theta G. From the graph, slope is equal to sine theta G over sine theta A. Therefore, slope is equal to 1 over refractive index. As the result, the refractive index of the glass is equal to 1.5. There are 4 graphs and 4 equations. Try to use the graph sketching skill you learned in this tutorial to match the graph with its corresponding equation. Graph A, y-axis is S, and the x-axis is t. Its corresponding equation should be S equal to Vt. Graph B, y-axis is V, and the x-axis is t. Its corresponding equation should be V equal to At plus U. And graph C, y-axis is S, and the x-axis is t squared. Its corresponding equation should be S equal to Ut plus half At squared. And in the last question, y-axis is V squared and the x-axis is S. Its corresponding equation should be V squared equal to 2as plus V squared plus U squared. Now you can use a couple of minutes to find the slope and the y-intercept of each graph. In graph A, slope is equal to V and the y-intercept is 0. Graph B, slope is equal to A and the y-intercept is U. Graph C, slope is equal to half A and y-intercept is equal to 0. And in the last graph, slope is equal to 2a and the y-intercept is equal to 0. Hope these graph sketching skills can be useful for you. Bye.